Okay, so for this video, we're going to talk about kinematic equation. So this particular video will tell you how you're going to use the equation or formula that are involved in kinematics. So by this point, I hope you already understand the basic terms that would be involved in this principle. These terms that I'm referring to are velocity, speed, distance, acceleration, and time. So these particular terms are very important in kinematics because this will also tell you, or this will help you in choosing what is the correct formula in such or in dealing with problem solving in kinematics. So that is the very first thing that you need to know, because most of the time you'll get confused on what is the correct formula to use, since there are a lot of formulas involved. But then I hope with this one, when we talk about how these formulas are derived, you'll be able to understand more about choosing the correct formula. Okay, so let's start first with the first formula. So you have here x of f is equal to x sub o plus vt. So your x there, that is actually your distance. I just represented it by the variable x. So if you multiply your v, which is your velocity, times time, you will get the distance. So I just included there x sub o because sometimes there are problems that the measurement of the distance did not start at 0. So if that's the case, we need to consider the initial starting point. So that's why we have x sub o. But then most of the time, most of the problem it would start at the origin. So I actually don't have to worry much about that one. So next you have v is equal to vf plus vo over 2. So that v actually is your average velocity. So if you have two velocities given, their average velocity is derived by adding the two velocities divided by 2. And this is for constant acceleration. Constant acceleration. So the third one, you have there vf is equal to vo plus 80. That is also how you're going to get velocity if acceleration is involved. Again, I added there vo since there could be some problems that have the initial value of the velocity not in 0. So we need also to consider the initial value for your velocity. Okay, so these three equations, also by the way, this is also for constant acceleration. So meaning acceleration is not changed. Okay, so for this one, again, there are some problems that would involve velocity, acceleration, and time in just one setting. So we're going to combine this equation so that we'll be able to get a much clearer formula, or a unified formula that has acceleration, velocity, and time, also with distance. Okay, so let's start with the first two equations. So you have xf is equal to x sub o plus vt. So your v, this one, that is actually the same value with your average velocity. So if you have a moving object, so the speed is the velocity. So if that particular object, you get the average velocity of that moving object, that would be the same as this one. So let's see. So you will have x sub f is equal to x sub o plus, again, your v and this v is the same. So meaning the value of your v could be represented by this one. So that means vf, that is final velocity, plus VO, which is your initial velocity, divided by 2 multiplied by your time. Okay. Next, so you have your value of your VO here. I mean, not your VO, but your VF. Sorry, not the value of your VO, but your VF. So your final velocity and this final velocity within the second equation are the same. So you can represent your VF using the third equation that has our acceleration present in it. So you can say XF is equal to X sub O plus, again, your VF can be represented by this one. So instead of using VF plus VO directly, you can represent VF by VO plus AT plus VO over 2 times T. Okay. Okay. Okay, next. So simplifying this one with the terms inside your parenthesis, you will have X sub F is equal to X sub O plus 2 VO plus 80 over 2 multiplied by your time. Okay, so you can simplify it further. You can divide, you can cancel this one. So X sub F is equal to X sub O plus, you multiply V times T, you will get V T, cancel your 2 because it is divided by 2, plus 1 divided by 2, you will have 1/2 A times T, then multiply by the T outside, you will have AT squared. So this is the combination of the first 3 given equation. This one. So if your equation, or if your problem involves distance, velocity, and acceleration, you can use this one. And if your problem in choosing the correct formula for this, let's say for example, in the problem there is no given acceleration, so you can just cancel this one and instead use V, T, and your X, which is your distance. So meaning whatever is involved, you can just add or plug in the values. If it's not present, you can just cancel it within your formula or within your equation. Okay.